Here's a redox balancing problem. We want to balance this reaction in acid. So let's go ahead and we'll go through all the steps that we need to do in order to do that. So the first thing we want to do is to break out our reaction into half reactions. And so we'll do that. And so we're going to basically link the carbon compounds together, and we're going to link the chromium-based compounds together, and that should get us where we need to be. So I'm going to go ahead and take those lines out. There we go. And so we've got C3H8O2 going to C3H4O4, and then we've got Cr2O7 2 minus going to Cr3 plus. Okay, and so we want to first balance the things other than hydrogen and oxygen. So on that first half reaction, all we have is carbon, and we have 3 carbons on both sides, so that's already balanced. Second half reaction, I've got 2 chromiums on the left. I've only got 1 chromium on the right, so I've got to put in a 2 for the chromiums there. So now our chromiums are balanced, and the next thing we want to do is to balance our oxygens and hydrogens. So we're going to balance our oxygens first, and we balance those with water. And so we've got, in the first reaction, we've got 2 oxygens on the left, we've got 4 oxygens on the right. And so I have to add 2 waters to that side to balance the oxygens. In the bottom, I've got 7 oxygens on the left and no oxygens on the right. So I need to add 7 waters to balance those oxygens out there. And now we've got to balance the hydrogens. In the top reaction, I've got a total of, let's change colors here, I've got a total of 12 hydrogens on the left. I've got 4 hydrogens on the right, and so I have to add 8 H pluses on the right hand side there. And in the second half reaction, I've got no hydrogens on the left, and I've got 14 hydrogens on the right, and so I need to add 14 hydrogens there. Okay, so now I should be mass balanced, and the next thing that I have to do is I have to add electrons to balance out the charge. Now to balance out the charge, in the top one, I have no charge on the left. I have 8 positives on the right. So I have to add electrons. So I'm going to add 8 electrons to make both charges 0 on both sides. And then on the bottom half reaction, I've got 14 pluses and 2 minuses. So it's a total of 12 pluses on the left. I've got 6 pluses on the right. And so I have to add 6 electrons here to make them equal to 6 plus on both sides. And now if we look at our electron balance here, we want to be able to add these 2 half reactions together in order to cancel out the and have the 2 amounts of electrons cancel out. So I've got 6 on the bottom, I've got 8 on the top. So I need the lowest common multiple between 6 and 8, and that's going to be 24. So I need to multiply the top reaction by 3, and I need to multiply the bottom reaction by 4. And so let's go ahead and just rewrite that out. And so we're going to have 6H2O plus 3 C3H8O2 going to 3 C3H4O4 plus 24 H plus, plus 24 electrons. And that bottom one, I'm going to have 24 electrons plus 56 H plus 4 dichromates going to 8 Cr3 plus 28 waters. Okay, so these are the 2 half reactions we want to add up. We can do a little bit of canceling here. I've got 6 waters there, And so I can cancel out 6 of those there and leave me with 22. I've got 24 H's there and 56 here. And so that will leave me with 32. My 24 electrons cancels with my 24 electrons. And that should be everything that I can do. And when I add all of that back up, what I get is 32 H plus 3 C3 H8O2 plus 4 Cr2O7s. That's going to go to 8 Cr3 plus 3 C3 H4O4 plus 22 waters. And if you go through and check the elemental balance and the charge balance, you'll find that everything in this particular set is completely balanced.